right? So a 230 volts 50 hertz supply is connected across resistor. Case 1. Find current and its impedance and show corresponding voltage and current phasors. Case 2. If this same supply is connected across inductor of 20 millihenry, repeat the problem. Similarly for capacitor of 100 microfarad. So let us see how can we do this. So here, so let me make that if something is given in the supply, this is very important, given things. So what they given is 230 volts 50 hertz. Remember hereafter, if supply is given with only magnitude, defaultly the given thing is what the RMS value of the voltage. And the phase of the source voltage is taken as 0 degree. These are defaultly assumed if it is not given. Given value is RMS first thing and its corresponding phase value will be 0 degree. They will not say these 2 points every time, just it is given in this form 230 volts 50 hertz, that's all. With this what can I write is that V bar is equal to 230 at an angle of 0 directly. Why? Because it is understood that given value is RMS value and given phase is 0 degree. Clear? Okay. Right. Now case 1. If it is a resistor. What we will do? See that how much is the resistance? 10 ohm. How much is the voltage now? V bar. How much is the current? That we need to determine. Now can you tell me how much is the current for this problem? Just like Ohm's law in the DC system, in the AC system also, voltage divided by resistance or impedance. If it is inductor and capacitor, those will be impedances. If it is only resistor, obviously resistance. But what is the change? Change here is that everything is in phasor form. See, voltages and currents all are like on top of it some bar is represented. Okay. So now tell me how much is the current? So 230 at an angle of 0 divided by 10. So which is equal to, I already told you, R at an angle of theta 1 divided by R at an angle of theta 2.
23, sir.
So 23 at an angle of 0. Don't forget here. So don't try to divide the phase and magnitude. Always try to make that as a pair. Whenever you are writing something, magnitude and angle both must be there. Don't forget any one. Okay. So this is what the current. Now it is simple that so we can put these two things into phasor form. So voltage is existing at an angle of 0. How much is the voltage value? 230 means this line length is 230 equivalent. What about current? Current is also existing at the 0 degree position, but its length is lesser value. So this is 23. So this red color one is what the current phasor and this black color one is what the voltage phasors. And from this we can say that V and I are in phase or in phase. In phase in the sense that both are having same phase angle. For example, another way, if voltage is equal to, you tell me now, something like 230 at an angle of 20 degrees. What will be the current phase for a resistor? What will be the current? Leave the magnitude. How much angle I will get for the current? From this statement, voltage and current are in phase for a resistor. That means if voltage angle is 0, current angle is also 0. That is the meaning. So now can I say this angle is also 20 degrees? Then only angle difference between voltage and current will be 0. Then only we can say both are in phase. Got my point?
Yes, sir.
In phase means it is not only the meaning that so both will have same angle, or you can also see in another perspective that angle between voltage and current is always 0. That's okay. So if voltage angle is 0, current angle is also 0. If voltage angle is 20, current angle is also 20. So that you need to understand. Clear? So now let us see for the other elements. Second element, inductor. Inductor. Now what is the inductance value L? 20 millihenry. And how much is the voltage? B. And we would like to determine how much is the current I. Now, can I write I is equal to V by L? Can I write like this? Why? Because L is only the given thing, no other things are given. As like resistor, what I had written here, I is equal to V by R. Can I write like this way? No, we need to work out something. What is that? Tell me. Whenever inductor or capacitors are there, we need to find its impedance ZL. If it is capacitor, its impedance ZC, which is equal to, we seen in the last session, how much we got? J omega L. Okay? So let us see how much is the ZL, which is equal to J omega L, which can also be written as JXL. It doesn't matter, whatever it may be. Now, this omega can be written as 2 pi f into L. Now we know everything. 2 pi f is frequency. How much? 50. How much is the L? 20 into 10 power minus 3. Millihenry, right? How much is this value? Tell me. Quickly. Quickly. Yes, anybody doing this?
360, sir. J360.
360 sir.
360 J.
Yes, sir.
Okay, no issue. So now this is what the ZL. This is what the ZL. Now we can apply our Ohm's law for this AC system as I is equal to V bar divided by ZL. But it is not simply L, it is ZL. So now how much is the V bar? 230 at an angle of 0 divided by, I already told you previously that this 360J can I write as 360 at an angle 90? Why? I told you 1 at an angle 90 is equal to J. Yes or no? So this
Yes, sir.
J, just simply I am writing 360 into 1 at an angle 90. 360 into 1 is 360. So if I'll express this in polar form, it is much easier for me. So 360 at an angle 90. So how much
Sir,
is this?
ZL 360 రావట్లేదు సార్.
Is it? So
సంథింగ్ 157/25 అని వస్తుంది సార్.
okay, then tell me that simplified value.
ఎస్ సార్. 6.28, sir.
6.28. Is that correct?
Yes, sir.
Other persons, anybody doing that? 6.28? Is that correct? This is a 10, so this 10 power 3 and this everything will go away. So pi is 3 point something into 2. So right, this is 6.28 only. Okay, so which can be written as 6.28 at an angle of 90. So now this is what? 6.28 at an angle of 90. 230 divided by 6.28, how much is the value? How much is the value?
36.62, sir.
36.62. How much is the angle? Tell me now. You should be in a position to say the angle clearly.
Minus 90. Minus
Exactly.
90, sir.
Minus 90. Very good. So now this is what the current. Which current? Inductor current. Now let us see the phasor of these voltage and current on the phasor diagram here somewhere. So where is the voltage? Voltage angle is 0. So can I say here somewhere this is the voltage whose length is 230, whose position of this vector is on the 0 degree line. Tell me where is the current? At minus 90. So from 0, from which side I have to
Clockwise.
move? Which side I have to move to get the negative angle?
Clockwise,
Clockwise.
sir.
So clockwise angles are referred as negative angles. So by how much angle I have to move? 90 degrees.
90, sir.
So somewhere here 90 degrees may be there. So there you try to draw a line with a length of 36.62 here, whose length is 36.62, whose position
Sir,
is
minus 36.62, sir.
why minus 36? Plus only, na madam? 230 divided by 6.28. So 36.62 length, this length of the vector is 36.62, but it is occupying the position in the negative direction. It doesn't matter. Okay. So at an angle of 90-degree position, which 90? Clockwise 90, not anti-clockwise. So this clockwise itself will represent negative nature. You will no need to say minus 90 here. Okay. Just simply represent this arrow in the clockwise. That clockwise nature itself will represent negativeness. So whose length is 36.62, whose position is at minus 90. Now tell me whether this current is lagging the voltage, this voltage, or leading the voltage. Tell me.
Lagging the voltage.
Yes. So current
Lagging.
I is lagging V by, tell me, 90 degrees. So just to
90 degrees.
get complete awareness on this lagging leading, I am taking these simple problems. So finally let us see the capacitor part. Third thing is what? The capacitor, like that kind of supply is connected across the capacitor, whose capacitance is how much? Capacitance how much I had given? 100 micro. 100 microfarad. Whenever we see inductor or capacitor, the first observation is, do we know its corresponding impedance? That's it. Just if we don't know, you evaluate it. So this voltage is V and this current we need to determine. So to get the current, I need the ZC. What is the ZC? Capacitive impedance. How can I write capacitive impedance? In many forms I can write as like this: 1 by J omega C. 1 by J can be written as minus J by omega C. This 1 by omega c can also be expressed as xc in any form. It doesn't matter. So now see that how much is omega 2 pi f. So I can write this as minus j by omega means 2 pi into f c. So tell me how much is 1 by 2 pi fc, that is 2 pi into 50 into c is 100 into 10 power minus 6. Micro means minus 6 microfarad, right? How much is this value? Tell me. Again just see this, 2 into 50 is 100. So 100 into 100 is, so 10 power 4. So 10 power 4 and 10 power minus 6. So 10 power minus 2 is left out. So pi into 10 power minus 2. So that becomes, tell me. Okay, 1 by pi into, yeah, something, j. That is 100 by pi minus, how much, madam? Yes, please. Give me this value quickly.
31.83, sir.
31.8
47, sir.
47 j minus, right? So this we can write as 31.847 minus 90 degree. Again I no need to dictate, I hope, these things. So minus j is equivalent to 1 at an angle of minus 90. If you want, you can make this 1 cos 90. So plus j 1 sin minus 90. How much you will get? So minus j. Okay. So leave that portion. Now what I need? Current. I is equal to V by ZC. See, just like DC system only. But extra work this we need to do. So this is 230 at an angle of 0 divided by, how much is this? 31.847 at an angle of minus 90. How much is 230 divided by 31.847? This magnitude. Then how much is the angle? Tell me. Plus 90, right?
7.22.
7.22, sir.
7.22 at an angle of plus 90. This is what the capacitor current. Just put these things on the phasor diagram format. So voltage is at the reference position 0 degrees, whose length is 230. This is what the voltage phasor. And current is at an angle of plus 90. So plus angles are measured in which direction?
Anti-clockwise.
Anti-clockwise direction. This is what positive angles position. So by how much angle? 90 degrees. How much is the length of this vector? 7.22, something like that. So this angle should be exactly 90 degrees as like this, whose length is 7.22. This is what the current phasor. Then angle between this is 90 degrees as like this. See, this counterclockwise arrow represents positiveness. You no need to say plus 90. So in case of inductor, that clockwise position itself will represent negativeness. Okay. So now you can see current is leading the voltage by 90 degrees, where in case of capacitor. These 3 points are very important. For those 3 points only, I try to give this problem. One is nature of the voltage and current are in phase for a resistor. Current lags the voltage in an inductor. Current leads the voltage in a capacitor. These are the 3 important points. Apart from that, the capacitive impedance is 1 by omega c, which can also be written as minus j by omega c, which can also be written as minus jxc, where xc is the capacitive reactance, which is equal to 1 by omega c. If you want, you can write here xc is equal to 1 by omega c. In the same way, for inductor, j omega L is the inductive impedance, which can also represented as J into XL, where XL is the inductive reactance, which is equal to omega L, whose units are ohms. So these points should be clear for everyone. Why? Because these are the basic terminology in understanding the AC system. Clear? Okay, thank you.